to all the manufacturer or the industry player, do you know your data can turn out to be your money in future? What do you think?
You mean we sell the data to someone?
Selling data. Want to know more? Let's Sembang AIoT. Hello, good afternoon.
Good afternoon, everyone.
Good afternoon, everyone. So, welcome to our Sembang AIoT world. Welcome to our AIoT world, okay? Thank you for watching. Great afternoon to all of you. Great morning or evening, wherever you are. So, myself, Cecily.
I'm Daniel.
Yeah. Okay. So, we'd like to just inform. Right. I think today is our session number 41, right? Yeah, 41. So, of course, 41 means something to me. I don't know whether, does it mean something to you, number 41?
No.
No. You want to know more about this 41? PM me. Okay. How can this data be, if I'm operating a manufacturing plant, when I'm running my process, I collect my data, this data can be valuable next time. It can turn out to be money. You think so?
Yes.
That is very interesting. Not only you can use it for yourself, you can also sell your data in future. That I think is going to be the trend. If some of you who follow us in our past session, we talk about this international data space, international data space association or society or something like that. We talk about some standard data sovereignty. You have authority, or you have your own authority in your own data. You can share. Next time you can sell. Of course, right now maybe not, but then in future that can be a trend. Okay, that's why in the whole we Sembang until today, from the past 8 months, we noticed that this data, when we talk to some of our clients, or talk to our partners, we always tell them this data is the most important thing right now. In fact, data set is very important thing. So today, of course, we will cover more something related to data. What kind of standardization that you can have? You see, you want to know whether your data can be sold or it can be very valuable. But then you must have something or some way of holding or hosting it or storing it, so that it's easier for you to sell in the future. Don't talk about sell first. When data is always important for you to use, especially the AI era, right now, everybody is talking about how you can do a data-driven thing. Yeah. So without data, you can't do anything actually. So that's why, go back to the old days, when people try to talk to you about data integration, IoT, data collection, building your historian, putting SCADA system to do data collection, for your long-term kind of use. That is actually already, I don't know whether in the past 20 years people know about that or not. Maybe they already seen, they already seen this, or they feel, something is going to take place. For example, in this era of AI, how does this AI era will affect the data collection, or what kind of impact that is given to this area? Yeah.
Okay, so this one is after the deep learning getting more popular. Before this, when you are doing the machine learning, data actually is not, we don't need so many data. But when we come to deep learning, we need a lot of data.
Right.
And why the data collection is not so popular during the machine learning time is, it also limit to the hardware limitation during that time. So even you want to get a 1 TB storage is very expensive.
Correct. Yeah.
20 years ago. Maybe one TB SSD may cost you a few thousand ringgit. But now it's become very cheap already.
I think that is due to the mainly two factors. One of them is computing power is actually triggering the AI process. It's actually boosting or is facilitating the whole AI, deep learning, whatever thing that is you're using. That computing power is already enough. Maybe it will go even higher. I just heard, I think there's an announcement by NVIDIA, is it? That they are going to launch something related to their superpower.
There's a
AI.
new GPU released recently.
New GPU release. So these are the things going on. So that's why when you look back, instead of course, having this data, how can you use the data to improve your process is one thing. We keep on circulating, we keep on talking about this part. How can you use your data to improve your process, to improve in terms of efficiency, doing forecasts or do prediction and so on. These are the areas that you'll be able to. But at the same time also, this set of data, how can that turn to become a money? How does this data can turn out to be money?
When someone needs your data,
when there's a demand, when there's demand, just like some of the company the company may be, to you think not so worthy of this company, but then if someone say, hey, I want to buy your company $2 million, you become 2 million. So same thing happened to your data. Let's say someone think that, hey, this data is very important for me to use in my AI model. So I may request from you. So if let's say this set of data is seldom people, because building data or getting this kind of data need time. Okay, you also spending money to collect those. Of course, usually is your first priority is for your own use. But being known or unknown, maybe you also don't know. Some days some people come to you, hey, I just want this set of data. Can you sell to me? Maybe I give you 100,000. I just want to buy this set of data. Can or not? Yeah,
it's possible.
It can be that way, especially when we have more this kind of data sovereignty, standardization. That's why today's topic also is something to do with this standardization. So talking about that, I think we want to just jump. Today we just do it a very special thing. We just jump direct to the demo. Can we? Is it better? Because Bulan Puasa, our colleague also want to go off early, so maybe we need to put this one in front. How do we start? Maybe you want to say.
We start with the
introduction to our colleague, is it? Okay, can we see your face? Hey, Amir. Amir is waiting. Yeah. Say hello. Say a few words to the audience.
Happy fasting.
Happy fasting. Okay. So maybe before Amir continue, maybe I just want to share one of the piece of our slide. Right now, today, I think we are jumping a little bit. Maybe just jump to the jump. One more. Jump one more. Okay. Maybe Ken Leong can describe from here before Amir can continue.
Okay.
So of course we have this industrial controller at the side. Yeah. So it's going to be the data will be pumping in from the controller.
From controller to the industrial PC. And then we have the SCADA software, the Administra, sitting inside the industrial PC.
Yeah.
Collecting all those data. And then this one is doing locally. So if let's say you want to share the data to the cloud, we also can, through the SCADA software, send to our cloud, the AIoT Edge Connect platform. Over there, we also have a cloud dashboard for you to visualize all your collected data.
Okay. So just to add a little bit more, of course, the industrial controller, I just want to make it real, more real at the actually in your maybe in your plant or in your production floors and this thing. You may have something like this industrial controller. It's very specialized industrial controller where it doesn't talk standard Modbus protocol. It doesn't talk any Modbus RTU or Modbus TCP. And then it don't have any standard. It's very old thing, that is keep on giving you some data, but it's measuring something, yeah. Maybe it's measuring the flow, maybe it's measuring the pressure. It could be also measuring the temperature, but it gives you the data in terms of 232 RS-232 serial communication format. So it's keep on sending data in the what they call in a burst. One time, in 2 seconds, you send you another one, and send you another one, keep on sending. So that one is coming from the left. And then, of course, we have our industrial PC there. So in this kind of situation, before we move on, maybe I may have to wait for a while. So before we move on, I think if you have this set of so-called this set of data that you want to collect, but it behave very old style, very old, very old style. Old style meaning it give you some proprietary kind of data communication with no standard, no standard. So how do you need to handle this kind of data normally? Without using. Because we are going to talk about these tools.
Yes.
How you can easily use these tools. Yeah. Before using these tools, how can we do that?
Before using this tool, actually, I want to ask, is this possible without the tool?
Is this possible without the tool? Of course, you can write a program, right?
Okay.
I can write a VB program. I can write a C programming, so I can put to the COM port. I listen to the COM port. Can I do that?
Yes, this is possible.
This is possible, right? So what kind of effort?
Yeah, to do this, spend a lot of time.
You have to do a lot of time. You spend a lot of time, right? That's why. That's also one of the reasons why we want to demonstrate this part to you. We have one of the tools. So these tools will allow you to handle this one differently. How different? Okay, we welcome Amir. Okay. So you want to switch your screen? Maybe we can turn on the screen. Okay, we already shared the screen here. Maybe with the assist of Kenyong, maybe Kenyong can continue to introduce a little bit. Anything, maybe we can ask Amir about that.
Okay.
Yeah.
Okay, so for this one, we have a SCADA that's showing the value. Okay, we have a simulator program. So it will keep on generate some value that representing the water level.
Yeah.
So the value will keep on increasing every second. And then the data is sending to the SCADA through the RS-232.
It's a 232 communication. Yeah. It's
Yes.
a very unstandard, very proprietary 232 communication. Yeah.
Yes, I spent a lot of time to write the Python program just to send out the value.
Okay.
But at the SCADA side, it's very simple. I think Amil can describe how we set up the driver in order to get the data.
Okay. So basically, we just create a tag, which is we insert how the text is insert based on the value that we want to retrieve, which is the value that we receive, and then we insert it on the graphic, which is the screen, as you can see here, as the runtime. So that so we also create a script which is to run the in back-end program for the value to appear. So as you can see here, we put a trend. This graph is a trend of our value. And also this is the value that appear every second when the data is received. And this is the object of the tank. So we can put any object, tank, maybe another tank to display it for human interface lah.
Yeah.
Like that.
Okay. Okay. So actually, basically, Amir was talking about how the whole SCADA screen is working right now. Yeah, it's working right now. As you can see, Amir already created the trending, and then you have an object to display how water level is showing. And I think the most important part. I don't know whether Amir can he stop the screen and then show the other part of the thing.
I mean, can you show the IDE part, the driver?
Yes. Okay. You can go to the driver part, Amir, maybe driver. Okay. Let me explain this part. Amir. I think Amir know how this one works lah. Okay. So in order to tap on to serial communication data, for example, in this case, what we did is we need to just configure the screen. You can configure in the screen. I don't know whether it's clear or not. Can you see? Maybe some audience, maybe you can see. Of course, serial communication we talk about. You need to configure the baud rate.
The baud rate.
Baud rate is very important. For example, in this case, what baud rate we are using? Amir?
So in this baud rate is on this, which is 9,600.
Correct. Okay, 9,600. Okay. So at the side there is one parity. Actually it's a non-parity. Most of the RS-232 communication right now is put to non-parity lah. So it's normally 8 data bit, non-parity, 8 and 1 stop bit. So 1 stop bit. And then right hand side you can see 10,000. Is it? Is it 10,000 or 1,000?
10,000.
10,000. That one is a timeout. That part is a timeout. So by using this configuration at the SCADA point, this SCADA is called Adistra SCADA platform. So we call it IIoT SCADA. So for this part, the refresh time is 1,006. 1,006 meaning 1.6 seconds, is it?
Yes.
1.6 seconds. So every 1.6 seconds, when it's okay, you need to connect physically lah. Yeah, you need to connect physically a communication port to the SCADA. So what you need to do is you assign a tag. This tag RX1, is it? Tag RX1 is basically listening to the port. Yeah. So whenever the data come in, whenever the data come in, it will be stored into the buffer inside. Then the tag RX will be filled by the data received.
Yes.
Yeah. This is how easy. And then of course, you also write some script, right, Amir? Yeah. So it performs some simple script. This script, maybe you want to explain this part. Okay. This script is written by what? In what?
This script is written in C#.
Okay. Yeah.
So it's basically just filter the input value. So because when we send the data, it's a combination of the integer and the string together. So we only want to take out the integer part. So we do some filtering here. We split it into 2 parts. Then we just take out the value. And then we assign it into another tag. So the other tag will store the data into the database for the alert, for the trending.
Okay, so this is how easy, This is how easy. These tools come with the C# basic tool or some of the library that already built for you, so you can use this library very easily. There's a guide for you to do so. First thing, you get the communication up to the buffer. Then the other part is how you manipulate. How you manipulate is just by scripting. There's some example of how to do that part. Once you get the data, that is how, can we switch to the screen again, to another screen, the display screen, your SCADA screen. Yeah. So when come here, is actually all the data is being tagged onto a tag. So you can make use of this data to do display right hand side on the tag level, or trending. You can plot a trending, and then you can also do some the bottom part. What is that? Is it the alarm?
Yeah, the alarm.
There's some alarm screen that you can build. In order to do this one, probably you just need 1-2 hours.
Yeah.
If you good in it, maybe 30 minutes also you can complete this one. This is how fast you can achieve from serial communication up to a SCADA. Then you can make use of the SCADA. You see, today we are talking about data collection. Data is very valuable. So we also don't want to be put on the roadblock to some of the things that we want to do, right? So these are the interesting and one of the valuable tools that you can use. But after that, maybe we have some more, right?
Yeah.
So maybe second part
going to send the data to the cloud.
Yeah. How do you send the data to the cloud?
Okay, so our cloud receives the data through the MQTT.
Yeah.
So the SCADA software also support the MQTT.
Yeah.
And then actually beside MQTT, we also support the RESTful API. But in this case, we just use the MQTT.
Yeah.
And then the data sending to our cloud is being encrypted by the SSL. And also you require the username and password in order to send the data to the MQTT broker on our cloud.
I see. Yeah, that I think is so the whole demonstration here. There are 3 very important parts. One of them is how easy to get data from a serial communication port. Just now I'll show you. The second part is what are the configuration or some sort of script that you need to do in order to manipulate your data. And then plus, we have one more MQTT driver, right?
Yes.
Can we show the MQTT driver also to the audience, so that we just, for the sake of doing a more complete one. This is the MQTT driver, right? Okay. So the MQTT driver, of course, in here we have some
to define our MQTT broker URL,
yeah.
the port, and then the username, password, and then we have the client certificate, and then we will set which tag we're going to use, and then the topic. You'll publish the data through which topic.
Okay.
Yeah. That's it. Very simple.
Okay. So I think the video need to be covered lah. The domain name.
Actually, it's okay.
It's okay.
They know domain name. Other people also cannot do anything unless they know your username, password, and have the certificate.
Okay. So we come to just now we have our step 1, serial communication. Step 2, configuration. Step 3 is showing data onto the SCADA screen, publishing to the cloud. The fourth one is what is the fourth one just now? Yeah, the fourth one is the detailed configuration of this MQTT how you can publish the data. This actually make up the whole thing. So if these tools will allow you to do what you call your data collection more easy. So yeah, so I think that is all for the. Is there any more?
Yeah, one more thing is besides you having a local database, when you send the data to a cloud, you also have a copy of data on the cloud. So anything goes wrong with your local database, you still have a backup.
Okay. Yeah, that's also very important. Okay, thank you, Amil. Thank you. Okay, let's come back to our this conversation again. Let's come back to our. So for those of you who has just watched us on this Sembang AIoT channel, me, Cecily, and Chen Leong,
Chen Leong.
we are doing this one regularly on Friday. Friday 4 o'clock, is it?
Yeah, 4
Our
o'clock.
standard
4
4 o'clock. So those of you who think this channel is relevant, do subscribe, like, and share. Yeah. Thank you very much for watching. But so let's move on to the second part. Yeah, second part. So shall we? I have okay. When we talk about industry, the other day we talked about industry revolution from 1.0, 2.0, 3.0. Yeah, 3.0. You can see the left-hand side of one of my slide there. When we talk about 3.0, well, you look at the right-hand side. 3.0, basically you have all of them, PLC, from the sensors to PLC to your edge, to your SCADA, to your MES, manufacturing execution system, to ERP, to the cloud application, and so on. This part, I think, basically on the 3.0 we have all. Yeah, we have all. So why is still 3.0?
Why is still 3.0?
No, at this moment, these are all totally connected. Okay, just mention another part. When we have all these things up to MES and below, these are all, okay, reverse, sorry. It's supposed to be OT at the bottom, the ID at the top, yeah. Mistake, typo, mistake. So with that part, why is it still Industry 3.0? Yeah.
Up to this part, you have the automation already, but you don't have autonomous, which require AI to help you.
Yeah, you see, when we mentioned about this IR4 require you to do data transparency, connectivity, and also one part is autonomous, yeah, decentralized, and so on. So in order for you to have a cyber physical system that can, automate, interconnect and make it autonomous, you need the data flow, the connectivity to be very well planned. Yeah. So that's why on the right-hand side, there is one part called, when we want to build a digital factory, unified namespace is also one of the area where it's very important. If you look at my slide at the left-hand side, automation control and system on this one, this kind of OOT thing, and then towards on the upper side, enterprise IT, both of them, one below and one up. So you need some kind of standardization, yeah, because we discussed about this standardization. ISA 95 is one of the standard where it provide you a kind of platform for you to integrate between the enterprise and the automation control system. Maybe OT and IT is being tied together or being integrated using this kind of standard. That's why without a standard, right now, actually, you go to most of the factory, these people, I mean, in this era 3.0 time, people don't care about connectivity. They buy the machines. Those machines are having non-standard, although they have standard, but they are not open. Maybe, let's say they are running with the Siemens PLC, or they are running an Omron PLC, but then some of them is still within themselves. It's not open. I believe most of the machines are already open. The only thing is for the sake of reliability, running, you want something to run properly. They don't want other people to interfere. They also don't want to open so much. So it's being very, 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 very close. So that's why we need a kind of standard to make this set of machines or data to appear outside. How do we do it? Normally, how do we do it?
How do we do it? So we need something that your machine and the outside world that they can communicate on.
You need some translator, right?
Yeah.
So that's why we have been
Something
talking our IoT gateway. Where is our IoT gateway? So our IoT gateway, although we show so many times already, but the important of the IoT gateway is there. Even the tools just now we use can be installed on the IoT gateway to do things that you want. It's actually out a lot of hassle of writing program, use a very unstandard thing. This part actually can help. So in this case, that's why if you really want to plan for standardization in the whole IR4 framework, these are the things, for example, in a unified space, they actually separate them in a enterprise, site, area, line, cell. It go on from the top to the top-down level. Yeah. So some of the PLC data will be stored inside. Of course, before that, you need a translator, for example, a gateway to gather and then to store in this unified namespace. So MES also do the same thing. Yeah, SCADA also publishing the same thing. But some of the information like ERP, they want to retrieve very short floor data. How they can do? They can through this namespace, you give them a different protocol. For example, in this case, most of them are using MQTT to do, or a RESTful API. These are the standard that we have. So in order to have these are the kind of standard that we are talking about on a macro level. Yeah, on a macro level. So let's move on. So on the micro level, we will have this set. For example, a more detailed one will be a device, sensors. Then you need what kind of protocol? A Modbus, or you need OPC UA. Yeah, some machine actually they come with the OPC UA. You can use OPC UA. A LoRaWAN, not very popular, but some you can still see some of these data collection through LoRaWAN, more on the remote side. And coming to gateway, we have this gateway layer. This gateway layer is basically talking to all your machines or machinery, or talking to your equipment, and then get all this data to publish to your cloud, or even the on-premise, for example, by itself, the unified namespace that hosts all the data can be also use that kind of MQTT kind of protocol. That's why standardization for this part is very important, especially that's why, for example, next time you want to buy machines, you have to put down a statement there. I need this ISA 995 kind of way of doing, or maybe give us some kind of protocol, or if you want to have a Modbus, or LoRaWAN, or OPC UA. These are the standards that you need to put in order for you to, in order to facilitate your future integration. Yeah. So yeah, that part, I think, of course, on the top there, you can have MQTT, you can have AMQP. MQP very seldom see. I think I heard there are people using also. Of course, REST API, they are quite standard. Okay, that part is on the micro level. So move on to the other side. So I just want to touch something related to MQTT. Maybe Kenon, you want to say something about this MQTT process?
Okay. Yeah. So for MQTT process to happen, first we need to have a MQTT broker first. It's like a middleman, where exchange the information between the publisher and the subscriber. So the publisher is the device that's sending out the data to the MQTT broker, and then the subscriber is the one who receives the data for further processing. So this is the most basic concept of the MQTT process.
Okay, so why this kind of why a lot of people like this MQTT is because of the you see the broker can serve a lot of publisher. Yeah, you can serve a lot of publishers. For example, just now I mentioned about SCADA. SCADA can be one of the publisher.
Yes.
PLC side can also directly become a publisher, or it go through some kind of gateway. Also, it can become a publisher.
Yeah.
And then what else? The MES also can be one part of publisher that they want to publish, and even go down to the very low level equipment, and also some sensors with the MQTT. Also, you can use a publisher. So interestingly enough, that the broker is able to host all the topic. They go by topic. So this topic, the subscriber know the topic, the username, password with the right security authentication, you can subscribe. Yeah, you can subscribe. So the data flow can be, very efficient, can be everywhere. Yeah, that's why with this protocol itself, standard protocol itself is able to help you to build a very healthy environment in making up the whole data acquisition system to host your future data set and so on. After that, what do we need to do? Normally, let's say we already collected all this data. What can we do?
After we collect the data, then the next step is we need to make sure our data set is clean. So maybe sometimes there's some noise in our data set or some corrupted data. You need to remove it before for the next step, which is the data analytic part.
Yeah, okay. We are actually preparing for data analytic, AI, deep learning, machine learning, or whatever, in the future. So that's why this part of standardization, which is very, very important in order to have that. Yeah. Can I move to the last slide? So that's it. Okay. This part actually I just showed, that was our demo. So we move on. Yeah, that's all. Yeah. So today we do it a little bit reverse a little bit lah. Yeah, we started the demo first. So you guys, if you like to see demo one, you can, you can enjoy our demo earlier this round. So that actually conclude the whole set of our Sembang AIoT part for today. We talk about standardization. We show you some of the tools that you can use to do good data collection. We also show some of the way how you can store data. For example, today we show a cloud interface. It can be also on-premise. It can be also on-premise. So for that part, you can have your data within your premise, without sharing to others yet. But coming back to the last part, when we ask, how can you sell data? What are the criteria that in order for you to be able to sell the data? What are the criteria?
Yeah. First, your data must be can be accessed by the person who want to purchase your data.
Easily available.
Yes.
Easily available.
And then second is, you also need to secure your data. Even though you want to sell your data, you also want to make sure your data won't be accessed by unauthorized person. If not, if everyone easily can access your data, then no point you sell your data anymore.
Okay. How can we achieve that?
How can we achieve that? Actually, when you host your data at the cloud or some data center, actually they already provide some security feature to help you to protect your data. But if it can become better if you have the data space, which you can have the full control on your data, how you share your data to others through the data space. That one is more even better.
Yeah, of course, data space is not something that you can control, because certain things is still going on. I think the standardization is being put up. Probably there are some people already practicing it, make use of that. But that part we want to see real able to use practically. We also don't know when. We don't know. But chances is, I think that should be the direction of the whole thing. Especially right now, the computing power is become more what they call the affordable, or more achievable. Things will change very fast.
The storage is
Yeah.
getting cheaper now.
Yeah. So, what are you waiting for? Some of the data collection that you want to do, but not all data you need to collect, lah. Yeah. Of course, priorities you should put up to those data points that affect your process first. You want something you want to monitor, and then usually this set of data will be used, can be used in the machine learning, AI, or in the future thing. Definitely. Not only, we are not talking about only these shop floor data. It can be your logistic data. It can be your customer data.
How they spend money, how frequent they buy.
What is the pattern of their spending, or what kind of what they call your sales data. It can be a lot, but of course on the AIoT part, we usually talk about talking to the machines, talking to the instrument and so on, because these are the easier. So you decide. They just follow your command to give you the data. Okay, yeah. So I think we have come to the end of this our sharing. But thank you very much for watching us. And then if same thing, if you like to, you find this channel relevant, please do subscribe, share, and also like us. And we want to end this one with Sembang bukan seberang Sembang.
Kita Sembang technology.
Kita Sembang AIoT. With that, we will see you in the next session. Bye-bye.
Bye-bye.
Have a good day. Bye-bye.